Welcome to Unfold Data Science. My name is Aman and I am a data scientist. In this video, I am going to continue my LLM playlist and build an end-to-end application for document semantic search. We are going to understand how LLMs can be so powerful using vector databases and some core LLM concepts of embedding and give you a foolproof semantic search engine. Let's build without any delay. So what we are going to understand is why semantic search using LLM needs to be done. Why we can't do using a normal keyword matching or normal word matching. Why we need a semantic search using LLM. Then we are going to understand high level architecture of what project we are going to build. Then I am going to touch base upon how you can do the fine tuning. Again, fine tuning is a very detailed topic which I am going to cover in upcoming separate video, but I am just going to give you a high level understanding of what is fine tuning when it comes to LLM powered applications. After that, I'm going to touch base upon one practical use of these kind of applications. So whenever you build a semantic search applications, right, you will normally go for a hybrid search. And the reason is we want to depend both on LLMs and traditional keyword matching. So how to build an hybrid search, we will cover. And then I'm going to show you everything using a UI with a very lovely software called Gradio. So let's see in the Gradio how the UI will look like for this project. First of all, why semantic search using LLM? So the meaning of semantic search is very simple. Suppose I have a question answer pair. So I have some questions and I have some answers. For example, this could be let's say patent related or copyright related information. So for example, here I can say, what is copyright? What is copyright? And here I can have an answer for this. Similarly, here I can have a question, for example, what is patent? And here I can have an answer for this. So imagine that there is a document like this. There is a question answers pair like this. And I want to train a model to which I can ask a question related on copyright, on patents, or any other things, and model should fetch me the relevant answers. Okay, so for example, if I ask something related to copyright, this is the right answer. If I ask something related to patent, this is the right answer. For this to happen, traditionally people have been doing the keyword matching thing, but keyword matching thing is not always good because we want to capture the context, we want to understand what the user is asking, and many things, right? Hence, semantic search using LLM has been proven to be very powerful. So one example which I remember by watching one of the podcast, somebody was telling, right? Suppose you ask to a system how to go from Mumbai to Delhi. Okay, so how to go from Mumbai to Delhi. And if you are doing a keyword search, right? And let's say the question here is how to go from Delhi to Mumbai. Then in keyword search, if you search Mumbai to Delhi also, right? It will show you the answer of Delhi to Mumbai, which means other way around. Hence, this is an example where your keyword search will not work. Okay. So what you need to do is you need to understand the context, the meaning, and then do the searching. That is where we use LLM powered semantic search. Now, what is the project we are going to build? So I have given you a high level understanding of what data we are having. So we are basically having a question answer pair. And what we are going to do is we are going to, let's say this will be our input data. So this is our input data or training data, you can say. Input data. What is this input data basically? This input data is basically QA pair. QA pair. What we are going to do is we are going to take this data and we are going to extract all the answers. So what we are going to extract? We are going to obviously put it in a pandas data frame. Extract answers. Fine. Once you extract answers, what you need to do is you need to obviously get embedding because you are using matching here, right, for semantic search. So you will get embeddings of these. And then a very important concepts come into picture that is known as vector databases. So what we are going to do is we are going to place the embeddings in a vector DB. So here what I am drawing here is basically a vector database, vector DB. Once you place your embeddings in vector databases, right, what you can do is when the user comes, so suppose this is a user comes with a query. So this is user query. This user query, you will again convert it to embedding, obviously. So this is original query. This is your embedding. And what we are going to do is you are going to take this embedding and hit this vector database with this embedding. And whatever match you are going to get, right, that match you are going to show that to the user. So this is a high level picture of what we are going to build. And most of these concepts you already know. You know what is embedding if you have been following my playlist. You know basic Python functionality, how to extract answer, how to put embedding. And vector databases, right? I encourage you to watch a Unfold Data Science video on vector database here. So if you see here, right, I'm in Unfold Data Science videos, and I'm just scrolling down. If you go around 1 year back, so I'm at 10 months back here. Keep scrolling and go 1 year back. Okay, so if you go 1 year ago here, right, you will see vector databases for beginners. This video is a 17 minutes long video. This will be very, very informative for you to understand vector databases and how it works. And then I have created one more video. If you see here, vector databases hands-on tutorial. So in these two videos, right, I completely show what is vector DB, how it works, how it stores embedding, how to fetch the information, how it is useful for building LLM powered applications. So those things you can learn from these two videos. And we are going to use a vector database is called FAISS in our tutorial today. So if you see here, right, I have already installed some packages. First, I have installed sentence transformer. Then I have installed FAISS, scikit-learn normal, Gradio I told you for UI purpose, and pandas you already know for data wrangling. And sentence transformers is basically I'll be using some BERT-based model, so I'm using this. And this is the architecture we are going to follow. So first of all, let's try to go ahead and try to build a simple semantic search project here. So what we need first for building our project, first of all, we need the data, right? As I was telling you, we need to create some data. So here is my question answer pair. If you see here, what is a patent? A patent is an exclusive right granted for an invention. How do I apply for a patent? To apply for a patent, submit an application, blah, blah, blah. So what I'm doing is I'm simply storing it in a query doc, this data frame. So as I was telling you, we will have a question answer pair. So question and answer, question and answer. That is what you can see here, query doc. Doc means answer. What we need to do next is we need to take these docs and we need to put this in the vector DB. But before that, what we need to do, we need to create the embeddings. And for that, we need the model. So I'm importing my sentence transformer. I'm importing my vector DB FAISS that I told you. And from the sentence transformer, I will take my model. So if you have been following my playlist, right? If you have been following my playlist on LLM for application development, you will know that last video I created an application using the same model. Using the same model, we have built the application of topic modeling here, topic modeling using LLM. For some of you who has not watched this playlist, you must watch this, otherwise the concepts will not be in a sequence, okay? Watch this playlist. Last time we used the same model to build a topic. So this will be useful for you. Same model we are taking here, mini LM L6. This is basically a BERT model. And then what we are going to do is we are going to generate some embeddings. How to generate the embeddings? Basically, we can simply say to the model to encode. So as you can see, I'm saying doc embeddings is equal to model.encode. The doc thing I'm taking from the top, this doc, and I'm creating the embeddings. And this will be the dimension of my embedding. So if you remember from my last video, I was telling you dimension of this model is always 384. So this is my 384 embedding dimension. Now what I need to do is I need to put this into vector DB, these embeddings. So if you see here, I'm initializing an index from faz and I'm saying index flat L2. You have to tell me in comment why I'm using flat L2, why not any other thing. So this FastDB provides other things as well. Why I'm using flat L2? Why not other embedding methods? And then I'm saying index.add doc embedding. So this will add my embeddings. Fine. And then what I'm going to do is I'm going to define a semantic search query function basically. And this function, it will take a query. It will encode that query. As I was telling you, I will encode my query and I will simply do an index search on query embedding. So index.search, this is my index where all my answers are stored. I will go here and I will search with my query embedding. Query embedding is what? My model query. And it will simply give me top 3 results. So now what I can do is I can run this semantic search function with some question. For example, here the question is what is a patent? So I will change it a bit and I will say, tell me about patent. Tell me about patent. So a patent is an exclusive right, something United States Patent and Trademark Office after a patent expires. So it is telling me some three top information about patents. So we have built our basic semantic search engine using LLM. Fine. But for practical purposes, we always build something more sophisticated. And one of the thing that you build is basically fine-tuned version of your model. So here, if you see, right, I'm using the original model. This is my original model. Original model. What I'm telling you is, for practical purposes, we normally use fine-tuned model. I'm going to cover in a detailed video how fine-tuning works, what is fine-tuning. But for you to just have an understanding of why fine-tuning. So normally these models, right? These models are good in generic tasks, but these models are not good in specific domain tasks. What we are going to build here is we are going to build something very specific if you see here. Okay. So for this, can I train my model on some more data? And that part is basically called fine-tuning. And fine-tuning, I'm going to cover in my next video in too much of detail. Don't worry about that. But just try to understand that what you have here is a powerful model, but generic model. What you have here is a powerful model, but generic model. What I want to build is a model which is specific to my domain and is more usable for me. And for that, what I need is some data which can make my model more usable for my particular work. So, as I told you, we need some data which can help us to do the fine tuning. Okay. So let me put some data. Don't expect this model to be a kind of very different from the original model, but this is just to give you a high level understanding of concept and increase that curiosity in you, what we are going to cover in next video about fine tuning. Okay. So here, if you see, I'm taking input example from sentence transformer. And in this input example, what I'm going to give is some examples of what is right set of question answer pair and what is not right set of question answer pair. Let me try to show you that. But before that, I have to disable one thing. Otherwise, it transformer module goes to WAND DB and ask for some API code, which I don't want it to do. Okay, so don't worry about these two paragraphs. This is just about disabling something in transformer module. Otherwise, logging will happen. So I'm just disabling the logging. If you see here, disables when DB TensorBoard, etc. So I'm not logging my training. Fine. So I have done that. But now the main thing is, as I told you, I need some examples which I can tell to the model that, hey, this is my domain specific example. So if you see here, I have imported input example and I'm saying train example is equal to input example. What is patent? Correct answer and label is 1. 1 means that's the right combination. How to apply a patent? Correct answer. Label is 1. 1 means that's the right answer. What is copyright? Photosynthesis is a process used by plants, not related. So this is not related means this is not a right answer. So label is equal to 0. What is trademark? Trademark protects brand identity. Level 1. So what I'm trying to do is I'm trying to prepare some data which will say to the model that in my domain, in my area, this is how question answer pair should look like. right pair and wrong pair, both examples I'm giving. So this data I will use for fine tuning my model to make my model more intelligent in my domain, right? And then once you have the data, right, it's very simple. You can simply say train data loader is equal to data loader, then train examples, and then train loss is equal to loss. Cosine similarity you can take and pass your original model here. So that's it. And then what you can do is you can fit your model and save it somewhere. So for example, model.fit, train data loader, train loss, and you can save it in, let's say, fine-tuned legal expert name. You can save it. Fine. So what I'm trying to show you here is a very clear example of how fine-tuning works. There are many details of this which I'm going to cover in next video, but understand that this is how the core funda of fine-tuning. You need some additional data and you need your original model that you will train on this additional data. That is your fine-tuning. So now this is my fine-tuned model that I have saved. What I can do now, run I can simply run my operations on my fine-tuned model. That's not a problem. So now I will replace my model object with my fine-tuned model. Okay, and once I have done that, right, what I can do is I can store my embeddings using this fine-tuned model. So you remember in the beginning we encoded using the model and then stored in the DB, right? So same thing I'm repeating because my model is fine-tuned now. So I want to use this fine-tuned model now. Done. Once this is done, as before, I can simply run a semantic search again. What to do after my patent expired? So this is now my fine-tuned model running. So initially we built a normal model. Later we created some data and built a fine-tuned model. Now you have to tell me an example. What do you think would have changed in the background? In the comment you have to tell me what do you think would have changed in the background when I fine-tuned in terms of embedding. What do you think would have changed? Tell me based on your understanding of how LLM embedding works. Okay. Now we have covered how normal model is working and how a simple fine-tuned model is working. But as I was telling you in the beginning, for practical purposes, right? Normally we use a combination of model and keyword search. So for keyword search, I'm using a TF-IDF vectorizer here, and it will simply, compute TF-IDF, and it will simply bring a combination of keyword search and this function that I'm writing, hybrid search. Okay. So here what you can do is query is basically input query that you want to search on. Alpha is basically to what degree you want to have a combination of hybrid, and top K is how many results you want. What is happening in this entire function is basically hybrid search will work in two parts. One is keyword based, another is semantic based using model, fine-tuned model basically, and it will combine the results. So if you see here, final score is equal to alpha, which is coming from here, semantic score rank plus 1 minus alpha multiplied by keyword score IDX. So basically we are taking two parts, alpha multiplied by semantic score rank. This is your semantic search. 1 minus alpha multiplied by keyword score. This is your keyword search. And the final score will be given, and based on final score, the ranking will be done. So what we are doing, we are mixing the keyword search and the semantic search LLM powered. So let me run this. And what you can do is you can simply run something like this. For doc score in hybrid search, what to do after my payment expired, it will give you 3 answers. A patent expires, and the score also, the round, basically the complete score. This is an example of how your hybrid search will work. Fine. Now let's get a feeling of doing the same thing in UI as well. And there is a very nice framework called Gradio. You can do that using Gradio. So I'm importing Gradio. Gradio is giving me a search interface. Result will be hybrid search output using query and alpha. So hybrid search is this function. Fine. And here I'm just putting an interface where this is a search interface, basically a UI creation. Okay. I'm running this. And as you can see here, it will give me a link. If I click on this link, right, you can see domain aware hybrid search legal thing is opening. And here I can ask a question. For example, what is patent and how it works? Submit. It is giving me a patent is an exclusive right. United States patent after a patent expires. Okay. I can say here, what is copyright and how it works. And I can change the alpha, means how much I want the keyword search and how much I want the semantic LLM search, right? So it is giving me copyright related information. So what we have done just now is we have built an end-to-end application, end-to-end project, and we have covered four different things. One is building a simple semantic search engine using LLM. Second is fine-tuning using some additional data. Third is building a hybrid search using keyword plus LLM-powered semantic search. And fourth is, bringing everything together in terms of a UI. As part of my next lecture, what I'm going to cover is I'm going to cover details of fine-tuning, because that is a very important part of LLM applications. But before that, I also want to tell you, you have to go to Unfold Data Science and watch a video on fine tuning, okay, so that you are ready for the next video. So if you go here, right, you will see a video of how to fine tune LLM, or you can search also. See here, how to fine tune LLM. Watch this video, it will be very clear to you on basics of fine tuning. Then obviously we will cover more details. And please drop a comment, guys, if you are liking the context, if you're liking the playlist. That gives me motivation, otherwise I feel demotivated. And I'll see you all in the next video, guys. This notebook I'll share with you. Wherever you are, stay safe and take care.